VIC matrix switchboard here. Pretty much did away with all the relays with the exception of the safety ground relay here, and of course my primary polarity, which is on the separate driver board here. But pretty much manual connections where you have this going out to the inductors. I'm sorry, this going to the diode, diode to the inductor, inductor to the output. On this side, it's coil out to inductor to cell. So pretty much a standard kind of setup here. Just no fancy schmancy controls to it. And dude, look at this real quick. You see everything there. It's immediately up to 40 volts. Hold up. Like immediately up to 40 volts here at, let's see, bump that 39.5. That's 40 volts right there. 10 amps, I'm sorry, 10 volts input at 1.56 amps. 15 watts of power. That's, yeah, we're already at 40 volts just at 10 volt input. 67 milliamps at the cell. $43 volts. About 20 volts over, we start maxing over something on the setup over there. This is the waveform. Interesting here. But, dude, we're certainly getting appropriate production. And, man. 43 volts at the cell right now. 33 watts of power. Waveform. Theorizing that once I get over this voltage level, that we have perhaps electrical arcing to the primary. Seeing that purple there, we get that and some ugly scratching here, but we got an easy 42 volts in the cell at 19 volts in, 2 amp. I'll take that. Might got some shorting happening or something somewhere. Today I just decided to play with a gapped core. We'll see what happens. I'm also sideways. There we are. There's the quick setup. That's my current frequency. That's what I'm getting. Easy 4 volts at 15 watts. But look at that purple and yellow. We're getting all that interference coming out really nasty. But we get up to like 42 volts. We get some nasty feedback there. I believe that is from the gapped core. I want to verify that real quick. Back to no gap. Sidebar, I also have this guy, which I kind of filed off and defiled to have a slight gap. That's for later. Right now we're doing no gap. Nope, still there. We got something else that is not related. I do hear static or arcing when I reach 42 volts at the cell. Back to gap. I hear the same thing. My signal goes crazy when that happens. When I switched primary polarity, I'm able to get up to 42 volts without that noise and distortion, but we have the pulse generated during the pulse off time. That static, or whatever we hear and see there, is a result of having that polarity reversed and the pulses being created during the pulse off time. During the pulse input, pulse off time. So here's the difference. Pulse on time, whereas previously the pulses were being generated, growing, expanding during that off period, that yellow PWM. Look at that there. 44 volts at the cell. Pretty good input, 3 amp, not bad. Nice waveform though, but you start to hear it kind of freaking out. I smell something, hang on. I forgot to put my fan on there. I can smell it. Make sure my safety relay is working. We're down to 0 volts. See, that's the thing here. With these stainless steel inductors, I'm able to achieve a higher voltage, but it seems like these get a lot hotter. They are resisting, because they're a resistive element. Obviously, you know, ask the question, how do resistors resist? Well, they have to convert that energy to something, so it's heat energy. It resists by converting electrical energy to heat. I mean, these things are spicy hot. So hot indeed, we are melting the hot glue that I use here. That's how you know you're getting too hot. Hot glue is melting, that's what I'm smelling. So, hang on a second. Okay, bro, hold the phone. Here we go. Yet again. This is just a bifilar secondary center tap, right? These feed into our inductors here. Or rather, should I say, inductor. We have one inductor here, one inductor, bifilar wrapped. So, you can see there's the center tap for that bifilar wrap here. But this is just inductor A going to that positive. There is no inductor B.
There is no spoon.
There is no spoon. Inductor B does not exist. It exists, but just on paper to prove the concept. It's not the actual thing of itself. We've got a bifilar secondary center tap floating ground. The positive of that feeds into this inductor, which is bifilar center tap floating ground, essentially. Right, just a standard bifilar setup going to the positive here. The negative here, green, is just directly bridged. Boom. Boom. It's just from the secondary's negative coil, that second coil after the center tap, to the cell. Look at this though. Bruh. Bruh. Look at that. Hold up. I'm gonna pause this just real quick. This is at low level too. Shit, what was that? Fucking 10 volts. Look at this. You know what? Hang on. I increased this here just for effect here. During that pulse on time, look at that. And we've seen this waveform before. Bam! Equal opposite being generated. Without that secondary, without that inductor B. Alright, we're going to continue this here. I'm going to quit rambling here and show you the meat. There's 40 volts at... Hold on. These are my stainless steel inductors, by the way. A stainless steel inductor, for that matter. We're going to tip this up to 40 volts right here. Not even 10 watts. 9 and 9 is 18, so less than 8 watts to produce 40 volts at the cell. And this is our frequency. We got 893, 53% in. I don't even know if that's optimal or not, but 52 milliamps at the cell. And hold up. I'm gonna see how high we can get here. There's that. Crazy waveform though. We've seen that waveform before. We got 43 volts at the cell. And production is kinda at for 40 volts. for 43 volts. I don't think this is an optimal waveform here. Perhaps this is where that variable inductor B does come in. I just need a tiny bit to balance it out. So we've seen that before as far as, you know, I've added resistance to either positive or negative, and it has affected the waveform on the opposite rail. I have a video of that. Maybe I can reference that actually, but inductor is going to introduce reactance to the equation, which be equivalent to resistance. Interesting. Let's try to switch some frequencies up here. Highest voltage at this frequency, 10 watts. Okay. Let's increase duty pulse. Woo! Definitely just went overboard on something. Hang on. I think you can almost tell when saturation happens. That waveform right there. Once we get up to, that's about max right there. Hear it change. See that purple getting introduced there? Noise in that purple rail. That waveform changes, shifts. Look at that. It's 29 volts in, 8 amps, but voltage is not highest because it starts doing that funky shit. Now for reverse polarity. Look at this. Hold up. We can only get up to 35 volts or so. That's the waveform. Hardly any production. Yeah, reduce the polarity on the inductor. That's back to standard. Feels like I'm able to scale fairly effortlessly up to 40 volts. 42, still only like a 1.5 amp. Much nicer production. Waveform, interesting. How high can we go here? It reached that threshold right there. Electronics guys, what is this when I get up to a certain voltage and that starts doing that? Is that saturation? Is that core saturation? Is that arcing to the primary? It's on the MOSFET too. Look at that MOSFET pulse off time. That just like EMF spike back. How do I get rid of that? Right about 25 volts in. .43 volts at the cell. 43 volts, 30 watts. Cool waveform. 100 milliamps at the cell. Cells are definitely producing appropriately. Yeah, cooking puppies. Shit. Okay. Waveform. I get the highest voltage here per frequency, but not the maximum voltage I'm able to get otherwise, because it caps out at 39 volts, because the waveform does this, like, that phase shifting thing again, like, still capped. Probably burning my shit up too. 7 amps. Surprisingly cool to the touch. Can't say the same for my MOSFET though. Upgrades. Make a note that my diode here was reversed the entire time. This should be coming from my secondary here, and this should be going to the next hop. So typically on these things I have input, output. So I swapped my secondary leads here. This guy is coming out of this side. This guy, whoops, this guy here in the red, coming out this side of it. But this is going to my diode an inductor now. Interesting how it's still giving me opposite polarity on this thing. Make note that all the previous videos here, at least since I switched this board up from relays to just manual connections, these two have been reversed. This indeed should be positive polarity out. So now that you know that, just pay attention if you're looking at my thing and be like, okay, that's positive, whatever. Yep, this should be correct now. Quick note about safety, y'all. I can't believe my eye isn't like completely bloodshot. Went out to the garage to kind of shave some things off this little piece right here to make it fit. And I forgot my safety glasses, so I'm like, oh, I'll just hold it over my face and I'll be fine. Just a quick little thing, bing, bang, boom. Well, of course, I got a little speck of this crap in my eye. Had to dig it out of there or whatever, flush it out with water, blah, blah, blah. Safety first, guys. Really. When it comes to electric tools, whatever, any tool, safety first. Ugh. There, it's so much nicer now. Not really, but I think version 2 of this, we're going to have some mounts right here specifically for this, or print a special piece to make that fit right on there. Modify this to open this up a little bit more so I can hit these buttons down here to release these snubber resistors. Maybe move this over just a slight bit, or move that back that way just a slight bit. Yeah, recess this down a little bit probably, so this will be flush against it. What's that? Probably like 5 millimeters or so. This place needs cleaned so bad. Oh my god. Maybe I'll make that my next montage of just cleaning this place. Where did I leave off? Jeez. Oh yeah, strange waveform. Voltage, but strange waveform. Reversing my primary here. Ah, look at waveform now. Nothing special there. 43 volts. Yeah, 6 amps. Pretty sure I got limitations over here. Perhaps a secondary coil. The stainless steel coil. Let me try something real quick. Reversing my diode. Definitely get higher voltage. We can achieve 46, no problem. 45. Cool waveform, but we have obviously some bug out there.
This is Stan's Revenge.